Hello everyone, Mr. Hissner here, and today we are starting logic. Logic is different than reason in that there is no nuance. Logical statements have, they're either true or false. There's no real in-between when we consider logical things. It is either a true statement or it is a false statement, and there's actually this notation that we write logic in. And this is a notation that is commonly seen um, in math, and actually, which is more prominent in the field of computer science. It's a way that we clearly and concisely identify logical operations, logical values, logical statements, in order to proceed and make conclusions that fit within the constraints of our statements. So today, that's what we're going to be starting to look at, and really that's what we're going to be doing for the next several days, next several weeks, is using logic in this way. So the first thing we have is a statement, and you guys are going to want to be taking notes on this. Our assignment is going to be take notes and submit them. So first we have a statement, and a statement is either a statement is either true or false. A statement is either true or false. There's no in between, as I was saying. Let me just get my colors here. Yellow. Oh no. Okay, so your statement is either true or false. No in between. This true or false, the statement being true or false, this is what we call a truth value. So a truth value returns T or F. It's one or the other. And using statements are represented. So this is statements are represented using letters P, Q, sometimes R. And this would look like this. Here we have the statement P, right? And it says supplementary angles have a sum of 180 degrees. Is that true? We can examine the truth value of this statement, and yes, that is true. That is a true statement. So what we can do, we can actually do what's called a negation. And if you think of a negation in terms of if we have 7, can we negate 7? Yes, we can negate 7. How we negate 7 is multiplying it by -1, and then we have -7. And so this idea that we can negate a statement is actually true as well. The negation of a statement has the opposite truth value. The negation of a statement has the opposite truth value. And this is shown by what's called a tilde. It's a little squiggly thing. This is read not the statement, right? And so if we have not P, then we have supplementary angles do not have a sum of 180 degrees. And notice that it turns this value now false. So this idea that we can negate the statement, our statement was supplementary angles have a sum of 180, and then when we negate that, it is supplementary angles do not, there is not a sum, so that would be read as not P, the opposite of the statement. And that is what a negation looks like. It's that little tilde, and it's read not. And so just like compound sentences, we can have compound statements. We can have compound statements. And these are statements joined, so more than one, right? Statements joined by the words, and, or. So, of course, right, that's what compound statements look like. Very elementary compound statements. look like that in English, and they also look like this in logic. But this is the only way that we combine statements, that we make compound statements in logic. There's no words like but, yet, so. However, none of those things are true because all those things imply nuance. And or are very rigid. There's no it's this or that, and so we don't consider any other forms of compound statements. So what we can have is our conjunction. These are things that put things together, right? A conjunction. Conjunction statements contain the word and. So we would write this as like an upside down capital V. So this is read as P and Q, right? And so when both statements are true, the whole statement is true. So what that would look like is P is true, Q is true, then P and Q is true. Conversely, if we had, say, P is false and Q is true, then P and Q is false, right? Both of these values have to be true values for the conjunction to be true as well. Both of these values have to be true for the conjunction to be true. And finally, we have the disjunction. Disjunction. These are things that are juxtaposition. These are things that are at odds with one another. So these are put together by the word or. And oh no, I did this one wrong. That's my bad. This is a big A without the. This is an A without the little crossbar. That's my B. So yeah, P A. So that should be. That's my bad. That's my bad. Or is the upside down V. Yeah. So A. That's how I remember it. Is that and, right? And without the little bar there. So or is the upside down V. This is true when at least one of the values are true, right? So at least one statement is true. And so what that would look like is, if we had P is false, but Q is true, then P or Q is true. So that's what that would look like. And I'm just gonna, so now we have all of our notes. All of our notes here. One last look. And then we are going to just look at what an example of this looks like. So let's examine these statements here, P, Q, and R. There are 7 days in a week. That's true. March has 30 days. That's false. March has 31 days. October 31st is Halloween. Happy Halloween. So this is P and Q. So P and Q would be there are 7 days in a week. And Q, March has 30 days. Is that statement true? Well, over here, I'm just going to write what this looks like. This would be true and false. No. Is that statement true? There are 7 days a week and March has 30 days? Nope, that's not true. That's false. Truth value is false. Both of those things aren't true. What I'm going to do over here is look at my, let's see, March is 7 days a week. Let's see if we can have an or. So, okay. Let's do 6, not Q. So March does not have, right, because this tilde, this is saying not Q. March does not have 30 days. Or, what was the or? October 31st is Halloween is on October 31st. So this is a true statement, right? Because with the or statement, we only need one thing to be true, but this statement here is true, actually. Not Q is true, and R is also true. Halloween is on October 31st. So these values, this would be a true statement. So that's what I have for you guys. That's what we're going to be doing. And the second part of this is we're going to be examining statements, negating statements, and then looking at their own truth values.